All right, welcome to Women in Science and Engineering. My name is Dr. Ashley Spring, and I teach biology here at the Melbourne campus. Welcome. Women in Science and Engineering program at Eastern Florida State College is committed to the recruitment, retention, and advancement of underrepresented groups in science, technology, engineering, and math. WiSE is open to all students. I don't want that screen. I want this screen. We offer seminars with guest experts like Dr. Linda Thomas, who will be talking to you today. Each month we feature an expert in science, technology, engineering, and math. We also offer workshops, of which we have one coming up this semester, on finding your career path within STEM. We offer networking for future schools and employment on our website, www.easternflorida.edu/WiSE. There are recordings from previous seminars. There is the contact information from our previous guests and other mentors that are there for you to contact and ask questions about pursuing your career in that field. We also offer career mentoring, undergraduate research, and local excursions, field trips. Today we have Dr. Linda Thomas. Next month, Thursday, October 16th, we have two events. First on that day, we have the Finding Your Career workshop, which is from 2 to 2:45 in the Melbourne Auditorium. That's Building 4. It's under construction. If it's still under construction in October, it will take place here. After the workshop, then we have Bonnie Stone Hodge, who is an engineer by trade and has expanded to an engineering business consultant. She works with major airline companies and Harris and Holmes Regional Hospital and a number of other groups. And then to end our semester on Tuesday, November 18th, we have Dr. Hilary Swain, who's the Executive Director of Archbold Biological Station. We hope that you will join us for many of these events. And again, visit our website at www.easternflorida.edu/WiSE. If there is anything that we can provide to you, please let us know. Without further ado, I would like to present today's speaker, Dr. Linda Thomas. Thank you.
Thank you. I teach chemistry at Eastern Florida State College, and today I will be telling you my story about how I ended up here as an instructor, like with a PhD in chemistry, and I will present a few research findings that I found, which will help you if you feel that you're not able to do well in science and engineering field. So let's start with my story first. So I just wanted to let you know who first introduced me to science. It was my mom. When I was in second grade, I had an experiment that I had to do. I was studying about water cycle. So my mom, she was a science teacher. So I asked her, what is this water cycle? So she asked me to take little water in a pot and start boiling it. She helped me to put it on the stove. And then when it started boiling, she asked me to close it with the lid. So I closed it and I waited for some time. And then she said, okay, now go open and lift the lid. So when I lifted it, I could see water like suspended underneath that. So she said, this is what happens in water cycle. So then she explained, water from the oceans, the trees, all that evaporate, it goes up, cools, forms clouds, and it comes down. So, that explanation, that helped me so much because I understood what it is. So, everything, what I feel is how you are exposed to when you have a question, how do you get exposed to the way you get the answer, that affects us a lot, right? Don't you feel that? If you have a question, even in the classes that you take, when you get exposed in a very simple and a way that you can understand, doesn't that help you? So right from that small age, I had a liking towards science. I liked science. And in elementary school, we don't have segregation into physics, chemistry, biology, anything like that. So, but I liked science. Science was my favorite. Science and math was my favorite subjects. So when I was in elementary school and in middle school, I had, my ambition was to become a doctor, to go to medical school. But then two instructors, my high school teacher and my college professor, they changed my liking towards biology, and I kind of changed towards chemistry. My high school teacher, he was such a nice chemistry teacher because in my high school we had to study physics, biology, and chemistry. So this instructor, he was so nice when he explained the basic concepts in chemistry, like balancing equations, naming compounds, and all that. He explained it in such a nice way that it was so easy to remember what it is, how to do it. And so then I started slowly, changing from that biology to like chemistry liking. And after my high school, I joined in an undergraduate college. I took chemistry as my major, and my minor subjects were physics and math. And then in my undergraduate years, I had a professor who taught organic chemistry. He was such a nice professor. He taught organic chemistry mechanisms, like how you tell stories to a kindergartner. So you never forget stories. So if you don't forget that mechanism, it comes automatically when you start writing a mechanism. So these two teachers, they inspired me a lot when I was in my middle school and in my undergraduate. And after my undergraduation, I joined the same college to do my master's. And so it's like 3 years undergraduation, and then I have to do a 2-year master's over there. And only after my master's, I could go into any other field that I wanted. So then I continued my master's, and it's just when I went for master's, I have to just, I could only go into chemistry and different branches of chemistry, like physical chemistry, organic, analytical, inorganic, everything. So you have to study everything, and it's called pure chemistry, that, program that I was in. So then I finished my master's, and after I completed my master's, I wanted to teach at a college over there. So this professor who taught me that organic, he came and asked me, what's your plan now? So I said, I'm just planning to apply for a job and get into a college and start teaching. So he said, no, why don't you try for something like research or something, because I know you can do it. So I thought, when I saw other students who did research at the universities over there, I thought, oh God, I should have been like really super smart to do that. Maybe I won't be able to do that. But then he said, no, why don't you try? So, give it a try in combination with that hard work. That is what we need. Because if I didn't have that feeling, like, let me try, and the hard work that I did, I wouldn't be able to be here today. And it's not like when you see people who have all these degrees and all that, don't think life is smooth for them. It's not like you go straight on that road without any hindrance. No, there are lots and lots of hindrances on the way, and you have to overcome these hindrances. That's where you become successful. So I decided to go into research, and what I did was I didn't go directly for PhD, but there was another program called MPhil, which is Master of Philosophy. And that's a 1-year program, and this is back in India. So we have to finish our master's before we get into a PhD program over there. And so if you want to go into MPhil, it's just a 1-year research where you have to complete the theory part and then do a dissertation on that particular project. So I applied for the MPhil program because my professor, he said, no, you have to do it. So I applied for that, and I started getting interested in research by then. And so I applied for that, and then I got admission into a university where I started my MPhil. So when I went to meet a professor, we have to do it just like how you do PhD. You have to select an advisor and all that. So I wanted to do research in physical organic. That is, you take the organic molecule and you study the physical chemistry of that. So I did it in kinetics. So this professor who was doing his research in physical organic, he was a professor who didn't like female students in his lab because he thought female students won't work hard. So when I talked to my friends, they said, no, he's not going to take you. So I said, let me give it a try. And I went and asked him, and he looked at me like this, and he said, okay, I have this compound, go and do this study on that. I said, okay. And it was a really fast reaction. I had to record it. I had to do these many trials. I had to do the calculation, and I had to get back to him. So I did that, and I got back to him, and I showed him the results, and he looked at it and he said, you can join. Okay. So he was like impressed, like, the way I did it, and the results were all good. So again, my advice is whenever you feel that you're not able to do it, it's not a good thing to go further with that feeling. Stop it over there, give it a try, and that combination of hard work with that, let me try, it's the best thing that you can do. So I was talking to her just before the class, and she said math is something that she didn't like, but no, that's what I said. I told you, just try it, and then work hard on it. I'm sure you'll be successful in that. So that's fine. And then after my MPhil, I applied for the PhD program. I completed my PhD, and my PhD was for 6 years because after my MPhil, I got a job at the college, an undergraduate college, and I started my job over there. And there was a program where we could join for part-time PhD program because we were working full-time. So first 2 years, I worked part-time in my university. I did the part-time PhD, and I was working full-time. So I woke up like 5 in the morning. I had to get out at 6 from home. I had to catch the train because this college was a little far away from home because I was staying close to the university. And then the college started like at 10 to 4, and then reached back by train like around 7. And my husband was there at the train station to pick me up. We went home. We had dinner, straight to the university, to the lab to do research. And I was there like till 12:01, and then came back home, slept, woke up in the morning. This continued for 2 years. So I'm telling you, that's not smooth. You have hindrances, but the challenge, if you face a challenge, you have to overcome it. Then you are successful. I mean, that's the way how you encounter that. Don't get away from that. Don't try to avoid that. You have to face it. That's what my advice is. It was really hard because working full time and then coming back and working in the lab and then going. So and then weekends I spent more time in the lab. So then after 2 years, I applied for a scholarship. It's a federal government scholarship, and we have to submit a proposal. We have to go for the interview, and then they select us from that. So I got selected for that, and then I was awarded the scholarship. It was by the federal government, and then I decided to resign my full-time job and go to full-time PhD program. And so after 2 years, I started my full-time PhD program, and that went for next 4 years. So after the first 2 years, I had my first child. And when I was like 7 months pregnant, I had complications. So I was admitted in the hospital for the last 2 months. And then after the baby was born, after 4 weeks, I went back to research. But there was one thing. There was a lot of support from my family and my husband. My grandma came and lived with us. She stayed with us for 4 months, and she took care of the baby. And she fed the baby so much that she was so chubby. I still see the photos, and I remember my grandma. So, that helped, and that support was there. So I went back to do research. And then after 2 more years, I finished my lab, all my experimental part. And I started writing my thesis. And almost when I submitted my thesis, and 2 months later, I had my second child. And after like 2 weeks, I had my open defense and closed defense. You have to present your thesis at the end to an external examiner who comes to the university and does that. And then I got my PhD degree, and then we moved from India to Australia. And my husband is also a PhD in chemistry and material science, so we moved with 2 kids to Australia. He was doing research over there. I didn't work for 1 year, and then after 1 year, we moved to US. And then we started at University of Arizona, where I did my postdoc at University of Arizona with Dr. Joseph Perry. He is at Georgia Tech University now. So I did 1 year with him, and after that, when he moved to Georgia Tech, I joined for research with another professor over there. And after my postdoc over there, I started working as a faculty at a college over there. And during my postdoc, we had a third child and we have 3 children. So it was during all these studies and everything, we had all, I had the 3 children. So life was not smooth. You have so many difficulties, like you have kids, you have to balance everything. So it's difficult. But if you have that willpower, you can win. There is a saying, where there is a will, there is a way. Have you heard about that? So if you have that strong willpower, I'm telling you, you can encounter anything that comes in your life. So that's my brief story. And 3 years ago, we moved from Arizona to Florida, and that's how I ended up at Eastern Florida State College. So that's my brief story. And right from young age, I was really interested in, things that I see in nature. I'll give you an example. You have seen lotus plants, right? In the ponds and all that. So my hometown, we have lots of ponds. And there are these lotus plants in the ponds. And when I was small, I used to step in the water, pluck one leaf, and then play with it. I liked dropping the water on it and seeing how it rolls on the leaf. And I didn't think about it, why it is like that at that time. But when I grew up, I see the same pond every day. And I started thinking, why is it like that? Why is that forming those round ball-like structure and going over the leaf? Do you have any idea what's the reason for that? The reason is these leaves, it has small microscopic structures on it. And those small structures, it is hydrophobic. That means it is water hating. You have heard about hydrophilic and hydrophobic, right? So it's water, it doesn't like water. So what happens when you drop water on it, the contact angle becomes large. And that's why it forms this big ball-like thing. And it starts going over it. And it cleans the surface like that. It doesn't stay on it, just goes rolling over the leaf like that. It doesn't stay on the leaf. So this is what is science. You get the answer to your questions when you explore science, right? And I have other few examples. I'll give you a few more examples. You have seen these creatures, right? The geckos, how they walk on the walls and all that. Can we do that? No, right? But how does it do that? How is it? There were many theories that were put forward for explaining this, but actually what it is these gecko, it has hundreds of thousands of setae found on its footpaths. And each setae contains hundreds of spatulae on it, or it's the microscopic projections from each setae. And because of the van der Waals forces of attraction between that and the object, it is getting attracted towards it. So if you imagine all the setae in the footpath to get, if it was to act onto that surface, it could carry a weight of 133 kilograms. It's that strong intermolecular forces between the two. And dry glue was synthesized based on this theory. The application, scientists found out the reason why it is like that, and they applied that to something that's useful. Again, guys, when you get the answer, you can do that. When you have what is the reason behind that, you can apply that to so many things. And one more example that I have is about moth. What's that? What is it? How can this moth see even if the light is there's no light, even if it is dark? What is the secret behind that? It is the outer surface of the corneal lenses are covered with regular pattern of conical bumps. And so when the light enters from the air to the lens, in our eyes what happens is there is no bumps like that. So it gets reflected back. But because there is a sharp difference in the refractive index. But in this case, what happens is when the light enters, that the change in the refractive index it's slow. That's a gradient change because of the small, teeny tiny bumps on the surface. It's not just getting reflected because there's a gradient change in it, and because of that, the light is not getting reflected, but it is going into it, and it can take it into it. And this is the principle of solar cells. Because solar cells, you want all the light to be absorbed by the sample. You don't want it to reflect out. Only then there is a use of a solar cell, right? And the other example is anti-reflection. What is anti-reflection? You know, when you, the small like kind of, when you go on the roads, you can see, if you go on the wrong way, you see it reflecting back, right? What is that? You don't want the, so that's the principle behind these two applications. So again, where did we get these answers from? It's from science. So, you know, when you start thinking about it, you get the answers. When you start researching, you get the answers. But you should find interest in that. You should try and work hard. And it doesn't come automatically to you. You have to go find it. And that interest is what we need, guys. So with this, I just want to go over a few research findings, and it will be there in your mind that when you go over those research findings, if you feel that you feel the same what I have, I'm presenting. It's not something that is an inborn thing that you cannot get rid of it. You can easily overcome that hindrance. That's what I want to tell you. So let's go over that. And here. Okay. Next question before I go on to that. Is it possible to balance your personal life and work? Yes, it is possible. Don't think that if you go into a science field, your life is gone. No, you should learn how to balance that. That is where you are a real scientist then. Like you can devote your time for work, you can devote your time for your personal things, like your family, your spiritual life, your children, all that. So, try to do that balance. And if you develop that habit right from the young age, you will carry that on till the last, your whole lifetime. So next, I just wanted to go over a few research findings. And this is what we have. Women are underrepresented in many science and engineering occupations. If you look into biology, it's more than 50. But the other fields, especially engineering field, you'll find less than 7% of women in engineering field. And what's the reason for this? Why is this underrepresented, number over here? I have a few research findings that will help you to understand. And there were 8 research findings that was categorized under 3 different areas. 1, social and environmental factors. 2, the biased feeling that only men can do science and not women. And the third one is about colleges and university, but I won't be going into that. I'll be just going over the first 2 findings. So, what is that social and environmental factor that affects the less participation of women in science and engineering? So it was found that research findings say that girls' achievement and interest in math and science are shaped by the environment around them. One thing is the negative stereotypes. What is that? The negative stereotypes about girls and women's ability in math and science, that has a very big effect. And what is it? And because of that, there is adverse effect in their performance. And there are research findings for that. And it's because of that stereotype threat. What is the stereotype threat? The stereotype threat is a situation where a person fears that their performance will be evaluated based on a negative stereotype. For example, if you have a female student who's taking a math exam, and that student has that feeling that women are not good at math, that will have so much effect on her when she takes the exam, and because she thinks if I do it wrong, then it will reinforce what is there, right? The performance. If she does it wrong, or if she does poorly in that test, then it's going to reinforce it. So that will automatically make her not do good in that exam. So don't feel that you are not going to be good at math That this is not a fact. This is just a negative. It's not the truth. That's what I can say. And there was a research that was done on a group of students, male and female. They divided the group into two. And half of the group was told that men generally perform better than women. Okay? And the other half was told that there was no difference in gender. And the same test was given to both the groups. And this is the result from the first group where women performed really poor. And in the second one, they almost performed same. So if that was true, this would also show like this, right? This graph should also be like this graph, right? Right? So that's not true. So if you feel that you are not going to be good at math or science, don't feel like that. Again, try it. Give it a try in combination with hard work will help you. So don't think it's just for those super smart people. It's nothing like that. Everybody is super smart, right? It's hard work that makes you successful. Even if you're like super intelligent, if you don't work hard, there's nothing. You're not going to be successful, right? You have to work hard when you have to work hard. And how can you overcome this fear, this negative stereotype? Get exposed to those female role models in math and science who are really successful in their life. And encourage greater involvement and participation even at very young age. And teach students about stereotype threat. There's nothing, don't believe in that. Right? Next, a few research findings, okay? So the first point is, if you feel that you are not good at science and math, that's not true. You are good at science and math, right? First research finding. Second one, this was a research done by Dr. Coral, and she did this to a group of students in a high school class first, and then later on when she joined the university, she did this on a very big, large group of students. So her findings were that women are harder on themselves. And it is difficult to convince girls that even if they have that scientific ability, no matter how well they do, they don't trust that they are good in that. But the boys who performed not as good as girls, they continue to believe that they were good. So we think we are not good at that. No, we are good. And I'm not telling it to the male students who are sitting over here. That's the general, attitude that we have. But don't feel like that. And if you have that, get rid of that and then start working on what you want to be. Right? And any questions? So the belief about intelligence, there are two types. It's the fixed mindset and the growth mindset. And I purposely gave red and green color because green color represents growth. Okay? I want each one of you to have a growth mindset. What is that? Even if you face challenges, embrace it. And in spite of all those obstacles in front of you, try to overcome those obstacles. Any hurdle in front of you, overcome it. And see the power of effort. If you're being criticized, learn from the criticism and be inspired by others' success. That's what you need. If you follow these points, I'm telling you guys, you will be really successful in your life. And that's called the growth mindset. Don't go for the fixed mindset. You don't want challenges over there. And you give up easily when you have obstacles. You don't like criticism. And you're threatened when you see others being successful. No, never go for that. Okay? And this is for everybody, just not for women. It's for everybody. So, what are the facts that you must understand, guys? First, experience and learning develops your intelligence. It's not something that you must believe that when you're born, you are born with this much intelligence and it's not going to grow. No, it's going to grow lifelong. And your effort and hard work will be valued and admired. And we professors, we are over here. If you guys need any help, come to us, ask us. And we are here to help you. And don't feel, my students, they say that when they ask a question in the class, they say, oh, it's a stupid question. I tell them, no question is stupid. Every question is a good question. So maybe somebody else in the class has the same question but doesn't want to ask the same question. So there's no question that is stupid. Learn the values, love of challenge, love of hard work, and the ability to embrace and learn from the inevitable mistakes. Okay? And next, this is very interesting. The largest gender difference, this is from the research finding, is the cognitive ability is found in the area of spatial skills. And what is the spatial skills? It is like if you rotate the first block here, and what do you get? You get this, right? So what my question is, if you rotate this, what do you get? A, B, C, D, E? Which one? D, right? Yes. And you have seen small boys playing with building blocks, right? Right? That is what they develop. And it's so for the spatial skill, the largest and the most persistent gender gaps in cognitive skills is found in the area of mental rotation. And boys consistently outperform girls. But this is not an inborn quality. You can develop this by taking courses. And in short time, it has been proved. In short time, it can be improved with training. It's not something that you get when you're born. You can develop that skill. So these are some of the findings. And the last one is the bias that most people associated with science and math are male, and ladies or female, it's humanities and arts. No. There's no division like that. Okay? And so with that, I would like to tell you that, how does my research help my students? I want to encourage my students to go into the STEM field. And it's not just for female, all students. Everybody should go into more and more into the STEM field because it will maximize innovation, creativity, and competitiveness. And only then we can develop a world-class talent STEM field group, which is really essential for the growth of our country. Right? And with that, my final question is, can Spider-Man be real? Yes, scientists, they have developed a robot which can climb like this. So that is real. Thank you.
We have time for questions for Dr. Thomas.